not depression as in, depressed. Really, depression should mean like a drop in pressure, but we don't use it.
It's good to meet you.
Yes.
What's your favorite lesson that you about?
That's an interesting question. I have no idea. I like the ones that have a lot of math in them.
Are you excited? You like math?
Come on. I don't know.
Are you teaching honors or AP?
No.
College
We talked about that. I think I just going to teach college prep. It's a lot of work. I don't like to put in a lot of work.
Want to go to challenges though? You're crazy.
I'm lazy. All right, let's get started here. When stuff is dissolved in water. So this is sounding just like yesterday. The freezing point goes down. So, you mix anything in the water, boiling point goes up, freezing point goes down. This is why we salt the roads, right? Normally water freezes at 32, you throw some salt on it, lowers the freezing point to whatever, 25, 20, depends on the concentration.
Could you put like regular salt, table salt?
Any kind of salt, yep. Anything, that's actually usually what they use is regular table salt. They just have big chunks of it, they spread it out.
What about cat litter?
That's a good, interesting question. I don't know what's in cat litter, but basically anything that will dissolve in water. You can throw, Kool-Aid on the road and it'll lower the freezing point.
Really?
Yeah, iced tea mix. Sugar would get sticky afterwards, though, so that's why you. And also, remember with ionic substances, they break up into more particles, so it lowers the freezing point more. So, the equation, pretty straightforward. The change in temperature of the freezing point equals a constant. We'll call this one Kf times molality. And again, this is the concentration of individual particles, not the concentration of the substance. So I'm going to multiply by 2 or 3 or 4 if it's ionic. All right, so let's do a problem. Basically, the math today is going to be exactly the same as the math yesterday, except for we're going to use a different constant. Oh, I should give you what these things are, shouldn't I?
Yeah.
So let's do that. Well, you know delta TF, that's going to be change in freezing point. Everybody gets that freezing point and melting point mean the same thing, right?
Mm-hmm.
Go in one direction or the other, and the freezing and melting is the same temperature. And KF is, it's going to be negative because the freezing point's going down. So it's negative 1.86 degrees Celsius per mole. And so you see the freezing point changes a lot more than the boiling point does. No, 3 times more, roughly. All right, so let's do a problem with this. Let's say we, doing things together, it's we now. We mix 350 grams of sugar. That's too much to write. Table sugar is C12H22O12. No, we always do table salt. Let's do some other salt. Let's do potassium bromide.
Ooh.
Guys are way too excited.
What is that?
Some kind of salt has potassium and bromine in it. I don't know if you can eat it or not. I have no idea. All right. There's a lot of salts you can eat. You can eat a little bit of sodium iodide. That's an iodized salt. You can eat a little bit of sodium acetate. What? I don't know what's going on today. 700 grams of water. How much does the freezing point go down?
show them something?
Think about it. All right.
Okay.
So we want to do this. We got to find molality so we can find change in the freezing point. So to find molality, we got to find mass of the solution. We got to find number of moles. So let's do mass of the solution first. SOL. All right. So that's pretty simple. That's going to be 350 plus 700. Somebody get out a calculator and add those together.
Erase.
Those sarcasm.
Ready?
1,050 grams. And we have to convert this to kilograms, right?
Yep.
What's that?
1.0.
1.05 kilograms. All right, so we got the mass of the solution. Next step is find number of moles. N, it's N of the solute, the potassium bromide in this case. So that's going to be 350 grams divided by, what's the molar mass of potassium bromide?
Come on now.
Like 20,
Nah, don't get it.
40, and
Alright, so 39.
7.
Plus 79.
118.
118, thank
Thank
you.
you.
Woohoo!
I can't add in my head.
Grams per mole, right? All right, so 350 divided by 118, that's going to be almost 3. 2.96 moles of the solute. When we look at potassium bromide, we know this is going to break up into 2 particles in solution, so we're going to multiply by 2 times 2. That's going to be 5.92.
It's like the same thing we did yesterday.
This is exactly the same thing we did yesterday, except K is different. Okay, so let's find the molality. I guess we'll do it here. Mole equals, and it's going to be number of moles, 5.92 moles, divided by the mass of the solution, 1.05 kilograms, equals, that number's going to be like 5.8 or something. 5.6, fine. Whatever. Whoa. Okay, so we have concentration. That's going to get plugged into here. So if you're writing your notes, you should write this equation right below where we're at there. And now we're going to plug these numbers in. Delta T freezing point is negative 1.86 times that number, 5.6 molar. Now this is degrees Celsius per mole. Times 5.6 molar. What's up?
That word of the freezing point 60 or good?
Go.
Alright.
This is like the same thing except a different.
Different
Delta
constant.
T.
Yeah, this is the only thing that's different right here.
Alright.
K is different.
Did I say negative?
Negative. Because freezing point goes down.
I'll look that.
Boiling point goes up, freezing point goes down. All right, so 1.86 times 5.6, what do we get?
Negative 10.42.
Negative 10.42 degrees Celsius. So freezing point in Celsius starts out at 0, so it's going to go down to minus 10.42. Which in Fahrenheit would be, I don't know, about 12 degrees or something. Right, because you start at 32 in Fahrenheit. Go down. Questions? We good?
Here.
All right.